Welcome to the final chapter of my bookcase, where I will finish the assembly and coat it with polyurethane. Before I jump into the actual assembly, I decided on a minor change to the design by adding cabinet screws. So, back into 3D modeling world in Inventor, I need to add all of the holes for the screws to the sides and then add the screws to the assembly. First thing I need to do is change the texture so it's easier to see what I'm working on. Clicking on the Appearance pull-down, I will select a light neutral shade which will make it easier to see what I'm doing. In this case, I selected beige. Now I start a new sketch for the hole. First I delete one of the auto-projected edges and then project the edge of the rabbit, and you'll see why I do this in just a moment. Select the Point tool and put a single point close to the center of the rabbit. Now add a horizontal constraint to the center line and then a vertical constraint to the center of the projected line for the rabbit, and now you'll see why that was done. Finish the sketch. Then select the Hole tool and enter the parameters for the hole. In this case, I am using the standard close fit for a number 8 screw, as you can see in this machine screw chart. Now that I have one hole, it is time to create a pattern around it. Selecting the rectangular pattern tool and the hole, then I select the direction, enter 3 for the number of holes in this direction, and then the mid-plane button, resulting in 2 holes to either side of the original. I will leave it at a 1-inch spacing to be corrected later. First, need to configure the second direction since this is a 2-dimensional array. Needed to flip the direction since it was going the wrong way and entered 2 for the spacing. This will also be corrected in the next step. I used 2 for the spacing only to differentiate it between the horizontal spacing. Tick OK to finalize the pattern and then open up the Parameters dialog box to adjust the array. Moving the dialog box out of the way so we can watch what happens. I decided I wanted the outer holes to be 1 inch from each edge, and the design parameter for that dimension is named depth, and we can see it used in D1. Now to enter a simple formula based on the design parameters where depth is divided by 2, and you can see it puts the outer holes centered on the edge of the board. Now to subtract 1 from it, and it puts the holes exactly where I wanted them, 1 inch from the edge. Now to correct the other dimension of the array. Parameter D39 is the setting for the other dimension, and I know that because I entered the number 2. Now this dimension needs to be the same spacing as the shelves, and D37 needs to be adjusted to the number of shelves. We can also get these from the design parameters. Looking at the comments column, we can see where I added a note for shelf spacing that includes the formula for the shelf spacing. Instead of duplicating that formula, we just enter a reference to parameter D13 and watch the holes jump to the first dado cut. The D37 parameter is the number of shelves, but it is actually a zero-based count since it does not include the top, so we have to add a reference to the number of shelves plus 1, and now we see the holes for all the shelves. Since the dimensions for the holes are directly controlled by the design parameters, if I change the parameters, the dimensions for the holes will be automatically updated. Opening the bookcase assembly, we can see that all of the holes are ready for screws, but first back to the side to clear the color override so that it once again looks like wood. Now is time to add the screws. Browsing my assortment of hardware to find the model of the cabinet screw I'm using and insert it into the model. Using an insert constraint, I stick it into one of the holes, and now it is time to create another array. Selecting the screw and rectangular pattern, then the direction for the column and the direction for the row. Entering 3 for the number of screws in the column, but leaving the number of screws in the rows at 2 while changing the dimension to 5. These will be corrected in the Parameters dialog box. I'm guessing you already know what's about to happen. Here are the parameters for the array we just created. D19 is the horizontal spacing of the screws, and if you remember, that formula is depth divided by 2 minus 1. D18 is the shelf spacing, and that parameter was shared by the side. So we just scroll down to the bottom of the parameters dialog box to see what it is, and then enter it into the equation and watch the second row of screws jump to the correct position. For the number of rows, if you remember, was shelves plus 1, so I enter that for D20, and now we have all the screws for the shelves and top on one side. We could do the exact same thing and create an array of screws on the other side, but there is a much easier way using the mirror tool. Selecting the component pattern I just created, then clicking the mirror tool brings up the mirror component dialog box. Need to be careful here, or this operation will create new components which are literally a mirrored version of the original component, and I don't want that. The green symbol is a flag that indicates it's going to create new components, saving them as a new file. Click on the green symbol to change it to the yellow symbol with a cross on it, and it will reuse the components and just flip them across the mirror plane which hasn't been selected yet. Now selecting the mirror plane, expanding the bookshelf top, and then expanding the origin, picking the plane that is the center of the top. This is why it's very important to have your planes in the correct place when first modeling the part. I have seen many people not anticipate how the parts will be referenced in an assembly and fail to control where the part is constrained when it is created. Rotating the model, we can see the preview of where the screws will be placed, then tick the next button and then OK to complete. Time to get to work adding the screw holes. Here I am using my edge line transfer tool. I mark a line approximately centered on the rabbit and each of the dados, then transfer the line to the face using the transfer tool. Then flipping the board over to do the same thing on the other end. This is to help ensure that the screws are put on the center line of the rabbit and dados. Now to mark the center line using my T-square. The width of the board is 13 3/8 inches, making the center 6 11/16 inches. Marking the center point on one end and then the other end. To validate I'm in the center, I make sure the mark is the same distance from both edges by flipping the T-square. Now with a straight edge, I connect the two center marks, and now I have my center line. Using the same process, I mark a 1-inch line on both edges and ends for the outer screws and connect them with the straight edge. Last, marking the crossing point for the location of each screw. Now I get out the automatic center punch and I dink the location for each screw, and of course repeating that for the other side. Now all the parts are ready to pre-assemble, and that is when I drill pilot holes for the screws. Starting the pre-assembly to check the fit and alignment of all the parts. Coming up, we'll be drilling the screw pilot holes, and once that is done, the two identical sides will become a left and right, so I'm marking them left and right. Also, since the top and shelves up to this point were identical, I mark them as I put them in the assembly, marking each shelf with left and right and the level of the shelf 1 through 5. I'm doing quite a bit of inspecting as it goes together to be sure everything is where it is supposed to be. And a quick look around looks pretty good. I checked it out with a small square to make sure everything is good before continuing with the assembly. Here I set the drill depth just by holding a screw up next to the drill bit before tightening the chuck. I arbitrarily picked one shelf to start with and then drilled holes and installed the screws. I did the screw installation sequentially, making sure each shelf was pulled in where it was supposed to be. That is a very old Craftsman cordless screwdriver and one of the best ones I've had. It is a little slow but perfect because it is very difficult to over-torque a screw. I am guessing it is over 20 years old, and I've had to open it up and replace the batteries once. You can see that when I let off the trigger, the motor is locked up and I can just use it like a screwdriver. I have no idea if they still make these. The same day I narrated this script, one came up on eBay and I bought it for a spare. Cost me $13. And now here's my assembled bookcase minus the toe kick. Everything went together as expected and turned out square all the way around, and now it is time to cut and fit the last piece before gluing it all together. Toe kick clamped in place. It's a pencil. I place the board I selected for the toe kick and clamp it in place at the base, aligning it with the bottom skid plates. Then, using a pencil, I scribe the opening where it will be installed so that I can cut to fit. First cuts for the toe kick will be on the crosscut sled. I am using a straight edge to align the blade with the scribed line on the board and then make the cut. I intentionally cut oversized because this will be a match fit. I nibble at one end until it was close and then move to the bench sander. The intent is for it to be a friction fit. Now that it is done, it is time to rip it to height scribed on the board. This dimension is not too critical. If too short, likely no one would notice, but it can't be longer than the skid plates. Back to the table saw with the fence, but first I need to go back to the bookcase and identify which side is the keeper. If I cut on the wrong side of the line, then I will have trashed this board. Aligning the blade with the scribe on the line since the actual measurement does not matter. Again, since this is a match fit, I cut it oversized and nibble it down. One more cut and then checking with the straight edge to ensure it is just below the skid plates. Now is coming the tough part, marking the two arcs to cut out, and at this point in the project I had no idea how I was going to do it. After a bit of pondering, I came up with this idea. Clamping a straight edge to my folding workbench, I laid out the center line of the board as well as the center line and edges of the arcs to be cut. Then I had to go back to the model to find out the radius of the arc. Here we can see where I labeled the lines that are the center lines. The line on the far right is the edge of the board, and the one next to it is the end of the arc. In the center are two lines adjacent to the center line that would be the other end of the arc, if my idea works. Now to get out the tool I made for drawing large arcs or circles. Per the design, the arc should be about 19.5 inch radius. This is not a critical dimension, but both sides should have the same arc so it looks balanced. Using my 3D printed large radius compass tool, I measure out the guide string to about 19.5 inches to the center of the pencil holder and then tighten the string thumb screw. Now measuring out 19.5 inches from the apex of the arc on the board, mark the point and then tap in a nail which will be the pivot center for the arc tool. Installing the pencil in the tool so that it is just below the bottom face of the tool. Put the guide string eye over the pivot, check to be sure the pencil is at the apex of the arc, and then draw the arc. Now to get a close-up to see if the arc intersects the two projected endpoints. We can see it is almost perfect, so now to repeat the same thing on the other end. Seems like that was a good idea after all. On the bandsaw, rough cutting the arcs. I am horrible when cutting arcs on the bandsaw, so it is pretty ugly and it's going to require significant cleanup. Here we get a good look of how ugly this edge actually is, but my 3D printer to the rescue, I printed a sanding block with a 19.5 radius on one side, and I'm going to use that to clean up this arc. Clamped up in the carpenter's bench, we start cutting away with the custom sanding block. I mark the surface with a pencil as witness marks so I can see the progress of sanding. When all the pencil marks are gone, then the sanding is complete and I have an almost perfect arc. At least it will be close enough to where no one would notice. I changed from 120 grit to 100 because it was just cutting too slow. When the arc sanding is complete, I went back to 120 grit and then 220 to finish it off. Time to pull out the finish sander to finish all the faces, starting with 120 grit and ending with 320 grit sandpaper. If you'll notice here on the end cap of this board, I moved the identification marks from the pencil marks on the face to ink marks on the ends since I'm about to sand off all the marks on the faces. Also, final sanding the edging using my 90 degree and 45 degree sanding blocks with 220 grit sandpaper. Now I'm not going to make you watch, but I have to repeat this process on all of the other boards. Finally, all of the sanding is complete and it's time to put this thing together. Everything is labeled, all the holes are drilled, and the toe kick is ready. I will be using construction adhesive on this glue up. It will not drip or sag and has a long working time. I only have to be careful to use small amounts to limit the squeeze out. Let's get rid of the toe kick for the time being because that's going to be the last thing to go in. The first thing I do is to run my 18mm Dado sander through the cuts to make sure there's no tear out from when I drilled the holes. Putting the top in place with just a couple of screws to stabilize everything so it doesn't fall over. Now 2 more screws on the other side to hold it up. Adding some clamps and squares to hold everything in place, then I install and clamp the upper shelf. And again checking that all is square. Once I am satisfied everything is square, I will hold the shelf in place with some screws and then remove the top. Changing the configuration of the bar clamp to a spreader to open it up so that once glue is applied it can be easily slid into place without scraping off any of the glue. Before gluing, I cut out some squares from a magazine to place under the glue joints so I don't inadvertently glue the bookcase to the bench. A small bead of glue to the ends of the top, slide it in place, remove the spreader, and install the screws, confirming everything is still square and one is completed. Preparing for gluing in the shelf by pre-installing screws on both sides. Remove the shelf, apply the glue. Whoops! Almost forgot to place the glue protectors. Spread the sides out so that the glue doesn't scrape off on the faces while placing the shelf. Release the spreader and tighten the screws. Now to repeat that same process for all the other shelves. While reviewing installation for the toe kick, I decided to screw it on instead of just gluing it on. Browsing my selection of screws for some that are just the right length, I decided to use 3 2-inch screws, one on each end and one in the middle. Once I selected the screws, it was time to drill some pilot holes, and that means going back to the drill press. I did not want to reposition the camera just to show the drilling of the holes, but here they are, so now I need to transfer the holes by match drilling into the base shelf. I'm going to inset the toe kick, so I found a spacer board to keep it aligned and clamped the toe kick in place. Once that I was happy it was aligned, I drilled the pilot holes into the base shelf. Now back to the drill press to open up the holes in the toe kick to the shank size of the screw. Now it's time to glue in the toe kick. I am not concerned about squeeze out on this one since it will drip underneath where no one will see. My new bookcase is now assembled and ready for finishing. Back to my folding workbench and on my Lazy Susan turntable getting ready to spray the polyurethane. Rattle cans of polyurethane is ready, as well as a tack cloth and finishing feet. Prepping first by wiping down with a tack cloth to remove sanding dust. Then I put it up on the finishing feet, elevating it off the turntable. These also came from my 3D printer. Time to quote with the polyurethane. I have a fan running for ventilation and a ladder to reach the top. I start at the top and work my way down. Oops! No! The corners of the turntable go over the edge of the table and hit me in the leg, knocking it off the painting feet. I had to push it back a bit. When spray painting, always go past the edge before changing directions or you will have a buildup at the edges. Now have to wait 4 hours for the second coat. Actually, I had to wait 5 hours until it was dry enough for light sanding. It was cool and humid on this day, so dry time was extended. I used 220 paper on a sponge instead of a hard block so the paper conforms better to the entire surface. Although sanding was not required, I have found the first coat has a tendency to raise the grain a bit, and this takes care of it and allows the second coat to go on smooth. And here the second and final coat is going on. I had to move one of the fans due to blowback from the open door. Positioning it here provided a suction to pull the overspray away from me. Now look at my new bookcase. I will install the screws after the polyurethane is fully dry, and that will be tomorrow. All of the screws have been installed, and then it was time to clean up that clutter corner and put in my new bookcase. Now I'm on to the next project.